All right, today we are going to be doing page 68 and 69 in our instruction books. And our very first problem says Janae has 36 pennies. Nate has 23 pennies. Who has a composite number of pennies? If we look back in our chapter, we talked about composite on Monday. And composite numbers were where we had more than one factor. Prime numbers only had the number and 1. So these were the only way that the green beans could be arranged in equal rows, and that was prime. And these you could be arranged in other ways, and that would be a composite. So 24 is composite and 11 is prime. So if we come back here, it shows us we can solve this problem by drawing a picture. 36 pennies can be divided into 3 equal stacks of 12. 23 pennies cannot be divided into equal stacks. So who has a composite number? Composite is the one that can have other equal stacks. You can also use area models to help you understand the problem. With composite numbers, you can make area models that have more than one equal sized rows. So Janae's, here she has 1, 2, 3, 4 rows, 2, 3, 4, 5, 6, 7, and 9 columns. Or you can do one row with all 36. With Nate's pennies, it's a prime number and he can only make one equal sized row. Let's go ahead and start answering the questions about this. What factor pair is shown by Janae's stacks of pennies? So what factor pair is shown? 3 and 12. That factor pair. Is 36 a prime or composite number? So flip back to the first pages if you need to. We said at the beginning of this that Janae has the composite because hers can be arranged in other equal stacks. So composite. How do you know? You can arrange the rows or the pictures of the pennies into more than one row. Is 23 a prime or composite number? That was prime because there is only one way to arrange the rows or pennies. So if you're using a picture or if you're using an area model, you can either arrange the rows or arrange the pennies. This isn't equal, so it does not, you can't stack it in 2. Explain how you can use models to decide if a number is prime or composite. So here is our models. Here is a picture model, and this is an area model. It just says how can you use models. So either one of them, how can you use them to decide if the number is prime or composite? So here we're going to repeat what we said. If it is prime, so prime, there is only one way to arrange and that is to arrange boxes or pictures. And composite there are, we can say multiple or more than one. There are multiple ways. To arrange the boxes or pictures. Let's try solving some problems. Mrs. Reynaldo is picking up 17 playground balls after recess, and she wants to put the same number of balls into each ball bin. What are the different ways she could group the balls? So, we are going to play around and see how are the different ways that she can group these together. Grab a piece of paper. And so 17. So I know I can do one row of 17, right? One row of 17. And you can draw the 17 boxes. What about 2? If I try to do 2, I get 2, 4, because this is 1, 2, 3, 4, 6, 8, 10, 12, 13, 14, 15, 16, and 17. So that would not be an equal. So 2 does not work. What about 3 rows? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So all of this was too much. Is that an even row? No, so 3 doesn't work either. What about 4? And you, instead of erasing, you can color them in. So if we make 17, here's 4, 8, we're counting by 4s, 12, 16, and this would make 17. So we wouldn't use any of these. Is that an equal row? No. What about 5? 5, any number ends in 0 or 5. So that one's not going to work either because our number 17 ends in a 7. We have 6. All right, let's try it. 6, 12, 13, 14, 15, 16, 17. Is that a whole row? Nope, because it doesn't go all the way, so 6 doesn't work either. Man, what if I count by 7s? What if I don't draw the box? So let's count by 7s. 7, 14, 21, 28. Whoa, I already went way past 17. 7, 14, 21. I did not hit 17, so 7 won't work either. Let's try 8. 8, 16. Not going to hit 17 with 8 either. Let's try 9. 9, 18. Well, we already know we don't hit 9. So our question is asking, what are the different ways she could group the balls? She can only do one option, and her only option is one row and 17 in each row, in that row. So that right there tells us this is a prime number because 17, the only option we have is 17 and 1. Is 17 a prime number or a composite number? We're going to put prime. If you have any questions, please let me know.